Good morning, friends. This is Madhira Srinivas, Associate Professor and Training and Placement Officer, Department of Computer Science and Engineering, Swarna Bharati Institute of Science and Technology, Khammam. Friends, welcome to you all to our C classroom. Here today, in this lecture, we are going to discuss about some different concepts of structures, that is structure arrays within structures, structures within structures, they are called nested structures, and then Sizeof operator, typedef, how it can be used in C programs, and the last but not least is I give some programs for your practice, and then you are having assignment questions and some important questions which are covered in the previous examinations. So today lecture, this is lecture 4 on structures. In the first lecture we discussed about basics of the structures, and in the second class of structures we discussed few programs on structures, and in the third lecture on structures we discussed operations that can be performed on the structures and how array of structures are used in C program, what is its significance. These are the concepts which are covered till now, and today we are closing these structures by discussing three important concepts related to the structures. One is arrays within structures, and then structures within structures, and then Sizeof operator and typedef operator. So let us start with arrays within structures. This is the first topic today. We have used variables of primary data type inside the structure. Similarly, it is also possible for us to use arrays inside the structure. Inside the structure definition, it is possible to have structures as variables inside a structure. So if you are using arrays inside the structure, then it is called arrays in the structure. Already in our definition of structures in every program, we have been using arrays in structures. You take an example of textbook structure. So there we have used array, character array called title to store the title of the textbook. Similarly, we have used another character array, that is author, to store the person who wrote that textbook. Similarly, we have used name. It is also a array of characters. It is an array we have used inside the student structure. Then we have worked with another structure called employee. Inside the employee structure also we have used array. So like this, in every C program we have been using arrays in the structures. It is very common to use arrays inside the structures. How many arrays can be used inside a structure? You can use any number of arrays inside a structure. There is no problem. There is no limit. See, in structure textbook, we have used 2 arrays. And then inside the student structure, we have used only 1 array. Like that, you can use any number of arrays inside the structure. Now, see this student structure. Inside student structure, we have used an array, character array called name to store the name of the student. If you carefully observe here, we are using 6 variables S1, S2, S3 up to S6. All these variables are used to store scores made by the student in 6 different subjects. All these variables are declared as integer type because we have assumed that the marks are integer data type. So therefore we have used integer variables, and all these variables, instead of going with S1, S2, S3, S4, S5 and S6, all these 6 are integer type of variables. All these values, 6 values of these variables can be stored inside an array. We can declare another array inside this student structure to store the marks scores in 6 subjects of a student. So therefore we are modifying this student structure like this. See here, all other fields are same: hall ticket number, name of the student, and then total marks and percentage. All are same. Only the marks, instead of having 6 individual variables to store marks in 6 subjects, we are using only one array called S of 6. Means we have defined here an array with 6 elements. Each element can store an integer type of value. S of 6 means you are having 6 elements in the array. S0 to S5. Index number 0 to index number 5. So S of 0 to S of 5. Total 6 elements. S of 0 stores first subject marks. S of 1 stores marks scored in second subject. S of 2 stores marks scored in third subject. S of 5 stores marks scored by the student in sixth subject. Like this, instead of using S1, S2, S3, S4, S5 and S6 individual variables, you can use only one array variable which can store scores of a student in 6 subject. So for that purpose we have used S of 6. Now if you want to access students marks in first subject, means first subject's marks are stored in S of 0. So therefore you can write S of 0 is a member field tailored with the student structure variable. Suppose if you are having student structure variable as std, then you can write std dot S of 0. So that will give the marks scored by student in subject 1. If you want subject 6 marks, you can write std dot S of 6, S of 5. S of 5 gives the marks scored in 6th subject. Like that, structure variable name, dot operator, then S of I. I means the marks scored by the student in I plus 1th subject. So that is how you can write the structure variables. Now to see this, we will write a simple program, same student program, but here instead of having individual variables for storing marks in 6 subjects, we are using an array S of 6 for storing the marks scored by the student in 6 subjects. This is the definition of the student structure, and then this is the main function. There we have declared a structure variable called std, which is of type student structure, and then here we are reading the information from the user. Enter the hall ticket number and the name of the student. This message we are displaying on the screen. By looking at that message, user will enter student hall ticket number and then his name. So these variables these values we are storing inside the variable hall ticket number and name. So next statements are important. Next 2 statements. Printf, enter marks scored by the student in 6 subjects in a row. You are asking the user to enter marks scores of the student in 6 subjects. You are instructing the computer to read 6 values and store them in appropriate member fields. Here to store scores in 6 subjects, we are using array. We have declared an array with a capacity of 6 elements, S of 6. S of 0 stores the marks of first student. S of 1 marks scored by the student in second subject. S of 2 stores marks scored by the student in third subject. Like this. S of 6, S of 5 stores the marks scored by the student in sixth subject. Like this, the structure variable name is std dot followed by subject variable name. Here also structure variable std dot subject variable name S of 1 means S of 1 stores the marks scored by the student in second subject, like that. So every variable means array element is linked with structure variable to store the marks scored by the student in concerned subject. Like that, instead of writing std dot s1, std dot s2, what we are doing is, here we are using array std dot s of 0, std dot s of 1, std dot s of 2, std dot s of 3, like that, std dot s of 5, like that we have written. Now once the marks are entered by the user, then you can calculate the total marks. Same in whatever way we wrote here, the marks scores in 6 subjects, same variable names with the structure variable we use here. Std of s of 0, std dot s of 1, std dot s of 2, all this we are adding, so that you will be getting total marks. Total marks are stored in member field total, which is accessible using structure variable std dot total. So that is the total marks scored by the student. Once you get the total marks of the student, then you can calculate the student percentage using the formula total marks divided by 600 into 100. Temporarily the numerator we are converting it into float variables because we would like to have floating point division here. If you do not convert this into float type variable temporarily, what happens is numerator is integer divided by denominator is also integer. So integer divided by integer, you are going to miss fractional part in the integer division. To obtain that fractional part, either you have to convert numerator or denominator temporarily into float data type. So we are here converting numerator into float data type. Therefore, you will be getting fractional part in the division process. If you are getting fractional part, your percentage score will be more accurate. Since to store fractional part in the percentage, we declare this percentage field as float. Percentage is declared as a float data type because we would like to have accurate percentage for the student. Then we are displaying the details of the student. It is as usual hall ticket number, and then we are displaying name of the student, then subject wise marks, subject 1, subject 2 marks. Here subject 1 marks are stored in S of 0, subject 2 marks are stored in S of 1, like that. Subject 6 marks are stored in S of 5, S0 to S5. 6 subject marks we are displaying on the screen, followed by total marks and then percentage. Like this, a little change has been done when you are using structure for when you are using an array for storing the marks scores of the student in 6 subject. A little change. This program is not a difficult program. Like this you can use structures. Already we have been using structures. Same student program we have modified here. Already one array is already we are using inside the structure, and one more array we have used by little bit modifying that program. So this is about the arrays inside the structures. Any number of structures can be used inside the array. There is no limit. Then like arrays, you can also use structures inside another structure. One structure can be used inside another structure. This is nothing but if you are using anything inside other thing, similar type of other thing, then it is called nesting. This nesting concept we have discussed so many number of times when we were discussing conditional statements, if statement. There we discussed that one if statement can be used inside another if statement. When one if statement is used inside another if statement, it is called nesting of if statements. Similarly, when we were discussing switch statement, we discussed that one switch statement can be used inside another switch statement. It is called nesting of switch statement. Similarly, when we were discussing loop control statements means iterative statements. There also we discussed that one loop can be used inside another loop. When one loop is used inside another loop, then it is called nesting of loops. One for loop can be used inside another for loop, or one for loop can be used inside while loop, or for loop can be used inside do while loop. Means one loop can be used inside any other loop. That is called nesting. Like conditional statements are nested, like iterative statements are nested. Similarly, we can also nest structures. Means one structure can be used inside the another structure. So that is called, this concept is called structures within structures or nesting of structures. Let us see one example how this can be used. Here just note down this statement. One structure can be used inside another structure definition. It is called structures within structure, or it is also called nested structure. If you are using one structure inside the other structure, then it is called nesting of structures. How many structures can be used inside another structure? You can use any number of structures or structure variables inside the definition of another structure. There is no limit. So that depends upon the application. How many structure variables are used inside the definition of another structure variable? So that depends on the application or the problem that you are solving. Here we have taken one example, employee structure example. There we declared member fields like employee number, employee name as array of characters, then basic salary of the employee, then dearness allowance of the employee, then house rent allowance, then city allowance of the employee. When you calculate this basic salary, DA, HRA, CA, when you sum up them, when you add them, then you will be getting total salary of that employee. This structure we can modify such that it will be having one structure inside the another structure. For that, what we do is, these allowances, three allowances are mentioned here, DA, HRA and CA. These three allowances, DA, HRA, CA, these three allowances we declare as a separate structure. We call, since these are the allowances given to the employee, we define a separate structure called allowance. The allowance structure is defined to have these three member fields, DA, HRA and CA. See the definition here, how it is modified. Employee number, name, basic salary of the employee. So these three fields are same, first three fields. Coming to DA, HRA and CA allowances. For that we have created another structure definition. Inside struct employee definition, we have defined one more structure called allowance. The member fields of this allowance structure are DA, integer data type, HRA, integer data type, CA, integer data type. And for this we created a structure variable called allow. Allow is a structure variable which is of type allowance structure. Means inside this allow structure variable, you are having three member fields, DA, HRA, CA. To access these member fields, of allow structure variable, we write allow.da, allow.hra, allow.ca. But remember, allow is a structure variable inside the employee structure. To access this allow variable, we write the structure variable name of employee structure dot allow dot d. Like that we write. And float total salary, again it is a member field of employee structure. Now if you want to access a DA component of the employee, then this member field, inner means this is the member field of inner structure. To access inner member fields of a structure, that member field first should be linked with its structure variable, and this structure variable should be linked with outer structure variable, means employee, means outermost structure variable name dot inner structure variable name dot inner member field name. Like that you have to write. So this is another model. Here we have declared allowance structure separately outside the employee structure with 3 member fields. Then we have created a variables of type structure allowance inside the employee structure. So allow here. Allow is a variable, structure variable which is of type struct allowance. Means inside the allow structure variable you have these 3 member fields, allow.da, allow.hra, allow.ca. This is a structure variable called allowance structure. This structure variable is used inside the another structure variable called employee. So we can say that struct allowance structure is used inside another structure called employee structure. Means allowance structure is there inside employee structure. So therefore it is called nesting of structures or structures within the structure. Like this you can define 2 structures separately, and one structure variable can be used inside the another structure variable. But when you are using one structure variable inside another structure variable, the structure variable which you are going to use inside another structure, that structure variable type should be defined first, and then other structure definition you have to give. Inside that you can use the variables of first structure variable. Here if you write structure employee first and struct allowance next, then compiler will generate an error, because before using that variable, what is that variable type you should define first, and then that structure variables can be created and used inside the another structure variable. So allowance structure should be defined first, and its variable can be used next inside another structure definition. That is, means structures normally defined separately, and then their variables are declared inside the other structure members. This is the best way of defining the nested structure. Nested structures can be defined like this. You can define one structure inside the another structure, but this definition is rarely used by the programmers. A good programmer usually they go with the second model, this model you can use. Now you can access the DA component easily through its structure variable allow, but allow is a member field of again employee. Allow is connected with the structure variable of employee structure. So to access the inner members of the structure, chain the inner member field with the concerned structure variables from outermost structure to innermost structure. That is how we have discussed. Suppose if you wanted to access the DA member of inner structure variable, then how do you write? DA should be connected with the innermost structure variable allow, and which is part of outer structure variable, so EMP. So EMP dot allow dot DA. Like that you can access it, and you can assign the value, or you can use that innermost member field of the structure in the expressions like the normal variable. Now we will see one example program. We are declaring 2 structure variables like this, allowance. structure we have defined, and then employee structure. Inside the employee structure, as we discussed previously, we have declared a variable called allow. Allow is a structure variable which is of type struct allowance. Struct allowance definition is already given here, which contains 3 member fields DA, HRA, CA. Now we will read the employee salary details along with employee number and name. Then we will display them on the screen. It is very simple. We have created a structure variable EMP which is of type struct employee. Then we are asking the user to enter the employee number, employee name. So EMP number, EMP name we are reading. And then we are asking the salary details of the employee, basic salary, DA, HRA, CA. So basic salary can be directly read EMP.basic. To read DA, HRA, CA, because they are the innermost structure members of innermost structure, they should be linked with the innermost structure variable allow, which is linked with the outermost structure variable EMP. So therefore we wrote EMP.allow.DA, and here EMP.allow.HRA, EMP.allow.CA. Then calculating the total salary by summing all these salaries together. You will be getting total salary. Once total salary is computed for the employee, you can display the details of the employee on the screen. The salary details of the employee like this: employee number, employee name, and then basic salary of the employee, DA of the employee, HRA of the employee, CA of the employee, and then total salary of the employee. Like that you can display all these details. But while you are accessing the innermost member field of the structure variable, you have to link innermost structure variables there with their concerned structure variable. When you are using innermost member fields of a inner structure, you have to take care that innermost member fields of a structure should be properly linked with their structure variables, from outermost structure variable to innermost structure variable. They should be separated with the dot operator. Like that you can write. Okay. Next. So after having completing the second concept, let us move to the third concept. The third concept is, what is the significance of Sizeof operator? Actually, it is not size, it is a Sizeof operator. And then typedef keyword. Why this typedef is used? We are going to discuss the importance of these two, Sizeof operator and typedef. Sizeof operator is used to know the size of a structure or structure variable or an array, or you can determine the size of a variable. Already Sizeof operator we have discussed thoroughly when we were discussing operators. Sizeof operator is a special operator, there we discussed. It is used to know the size of a data type occupied by that data type in computer memory, or size of a variable occupied by the space in the computer memory, how much space it is occupying in the computer memory you can know, or you can know the space occupied by a constant in the computer memory. This is what we discussed when we were discussing operators. So Sizeof operator is used to determine the space occupied by a variable or constant or data type. Or similarly, you can use derived data types and user defined data type. Array is a derived data type. Pointer is a derived data type. How much size is being occupied by a pointer variable in a computer memory, you can determine using Sizeof operator. When you declare an array with the elements of primary data type or with the elements of structure variables, if you want to know size of the total size occupied by that array element in computer memory, then you can use Sizeof operator. So here we can use Sizeof operator to know how much space is occupied by a structure variable in the computer memory. So to know that, you can give the argument to the size of operator as a structure tag name you can give, or structure variable name you can give. Suppose I am giving here size of struct student, means keyword struct I am using, and structure name student also I am using. Student is the structure name, struct is the keyword which will define student structure. So after defining the student structure, if you write size of struct student, so it returns an integer value. That integer value should be interpreted as bytes. So that integer value tells how many bytes of space occupied by that student structure variable in the computer memory. That is the significance of the integer value returned by the size of operator. Suppose you have declared a structure variable called EMP. EMP is declared as a employee structure variable. How much space is occupied by this EMP structure variable in the computer memory? If you want to know, you can write size of EMP, variable name we are writing. Here directly we are writing structure name. You can write structure name or structure variable. Both are same. Anything you can write, it will returns an integer value. That integer value interpreted in terms of bytes. That bytes specifies how much space is occupied by that particular structure or structure variable in the computer memory. That is specified by this. So that is the significance of size of operator. Size of operator not only used with structures or structure variables, it can be used with the data types. Size of int if I write, then it returns the space occupied by the integer data type variable in the computer memory. If I write size of, suppose x is declared as a double data type variable, then size of x returns how much space is occupied by the variable x in the computer memory is returned by the size of operator. Like that you can write. Suppose if I write size of 3.5, 3.5 means it is a constant value. Directly I am writing constant, size of 3.5 means if I wanted to store the value 3.5 in computer memory, how much space is occupied by that constant value in computer memory? That is returned by size of operator. Like that you can use size of operator. So the arguments to the size of operator is a variable or a data type or a constant or a structure or an array. You can give any one of these as argument to the size of operator. Then size of operator returns an integer value. That integer value is interpreted as number of bytes of space occupied by that concerned variable or the data type in the computer memory. That is the significance of size of operator. Size of operator is widely used in dynamic memory allocation. When we are going to at the time of discussing this dynamic memory management techniques, we are going to use size of operator. Then coming to the typedef, this operator also we have already discussed the significance of size of operator. Typedef operator. Typedef operator, it is used to assign another name to the existing data type. That another name is called identifier. Identifier means name. You can assign a new name to the existing data type. If the existing data type name is so long, if you are not able to pronounce it every time, then you can assign a new name to that existing data type. Then you can call that data type with that new name. You have to remember here that it is very similar to assigning a nickname to a person. A person is having probably your friend. Your friend may be having a very long name. It is his virginal name or her virginal name. But that virginal name is long. Then you cannot call that person every time with that long name. You will feel it very difficult to use that long name. To overcome this, what we do is normally we will take a part of that name or completely we will assign some other name to that particular person, like Chinni or Sweetie, Cherry or Fruity or Pandu, like that. We will assign nickname. These names are called nickname. Means the person is having his original name, but he is given some another name, second name to that person. Using that second name we are assigning a name which is very simple and easy to remember and easy to pronounce. Like that we will use. Means the person now he is possessing his original name along with this nickname. You can refer that person using his original name, or you can refer that same person using his nickname. Whether you use nickname or original name, when you call that person with his original name or nickname, he will be responding. Similarly, if you feel that any existing data type name is very long, difficult to pronounce, like unsigned long integer, if you are having, that name is very difficult. So therefore you can assign another name to that data type. And now onwards you can call that data type with this your new name. But before assigning any new name to a existing data type, you must inform the compiler about that. You have to tell the compiler that for this data type, this existing data type, I am assigning this nickname. Now onwards I will call this data type with this name. You remember, wherever I use this name, you have to interpret that this name means this is the name of this existing data type. Like that you have to inform the compiler before you are using any new names. So that is informed to the compiler through typedef. Here I wrote one example. Typedef is the keyword that will inform the compiler that we are going to assign a new name to the existing data type. We are going to assign a new identifier to the existing data type. Here the data type is struct student, means student structure. To the student structure we are assigning the name std. Means you are informing the compiler that wherever you use your new name is std. You are telling the compiler that wherever you use this new name std, you are informing the compiler to interpret that std as student structure. Struct student. Std means you are informing the compiler that it should be interpreted it as struct student. Now onwards, once this definition is given to the compiler, now onwards you can use std. Wherever you use std, that std is interpreted or replaced by the compiler with the name struct student. Now instead of declaring the variable as struct student yes, I can write like this stds, because std is nothing but struct student. Wherever std is there, it is replaced with struct student. S means S is declared here as a structure variable which is of type student structure. It means writing stds or writing struct student s, both are same. Wherever std is there, it is replaced with struct student. Already you informed the compiler using typedef keyword and then you are writing. Now same typedef struct employee. Struct employee means you are assigning a new name emp. So using emp you can declare structure variables. Now emp e means you are telling the compiler that e is a variable which is of type emp structure. Emp structure means struct employee structure. Struct employee structure. That is what you are telling. So writing empe, wherever emp is there, compiler automatically interprets it as a struct employee. Therefore writing empe or struct employee, both are same. Struct employee you are calling it as emp. Already you informed the compiler using typedef. Like that, wherever you want to use struct employee, simply you can use emp. Writing struct employee, If it is difficult, you can use in that place EMP. Wherever you use EMP, compiler interpret it as struct employee. Here, wherever you want to use struct student, there you can use simply std. Std means compiler immediately interpret it as struct student. Like that, you can assign a new name to the existing data type. You have to remember, most important point here is typedef is not used to create new data types. It is not used to create new data type, but it is used to assign a new name to the existing data type. You can assign completely a new name to the existing data type. That is the significance of typedef. To demonstrate the purpose of Sizeof operator and typedef operators. Here also I wrote the name wrongly. You have to write it as Sizeof. And you have to remember that many people, when they are using Sizeof operator, they write size space off. You should not write like that. Size space off. Sizeof is complete word, one word. Sizeof. Without any space you have to write Sizeof operator. Here I wrote only size. Size of, YF off is there. You note that difference. Now we will look into one program to demonstrate how this Sizeof operator and typedef operators are used in the programs. We have used student. We have defined here student structure with all these member fields as discussed previously. So all these member fields are there, and then we are going to the main program. Inside the main program, we declared three variables, variable x, y, z, integer type variables, and we have created stds, because already stds, what is std? You are informed the compiler here in this statement by writing typedef struct student std. Means you are telling typedef keyword tells the compiler that we are going to assign a new name to some existing data type. What is that existing data type? Struct student. Already what is struct student we have defined. Struct student is a new user defined data type. Its format is like that. We have informed the compiler, and after informing the compiler, we have assigned a new name to this student structure. What is the new name we are assigning to this student structure? We are assigning a simple name called std. Wherever you use std, immediately compiler interpret that as student structure. Like that, we are defining the new name to the existing data type student structure through the keyword typedef. See, here we have created a structure variable s using a new name std. So since we wrote std here, compiler interprets std means struct student, means it is nothing but writing struct student s. It tells the compiler that s is a structure variable which is of type student structure. Means inside s you are having the member fields of the student structure. All these member fields are present inside the structure variable s. Now we will try to determine the size of the operator, size of the structure variables. See, here we are determining the size of the structure variable. Size of struct student. Struct student means we are giving the name of the student structure. Student structure. The name of the structure is student, and the tag name, this keyword is struct. Struct student. Directly we are using structure. So how much space is occupied by this student structure in the computer memory? That is returned by the Sizeof operator, and that value, integer value, stored in x. So x contains the size of student structure. Now look at the second statement. Y is equal to size of s. What is s here? S is declared as again student structure variable. Whether you use directly structure name or structure variable name, both are occupying the same space in the computer memory. So whatever value is written by the Sizeof operator in the first statement and stored in the variable x, same value is written by the Sizeof operator here, and same value is stored inside the variable y. Means x value and y value are same, because x contains the space occupied by the variable student structure, and y contain the variable s, how much space it is occupying the space occupied by the variable s in the computer memory. Both are same. Student structure, whatever space it is occupying, the variable s of student structure is also occupying same space. So therefore here x value and y values are same. Now here we wrote size of std. Std is the another name. Wherever std is used, it is assumed that it is interpreted as student structure. So therefore this statement also returns same value. So x, y and z values are same. Now we are displaying the values of variable x, variable y, variable z. For x we have used struct student. So therefore we wrote the size of struct student is so many bytes. X value we are printing here. And in the y we have stored the size means space occupied by the variable s. Therefore we wrote this statement. The size of student structure variable s is a student structure variable, is percentile d. There y value is printed at this percentile d place. And then we have used std. The size of std is, at this place we are printing the value of z at this percent d place. Here in all these three statements, x value, y value and z value are same. So therefore same values are printed. Means you can understand that to the size of operator you can give structure name as an argument or structure variable name as an argument like s, or whatever new name you are assigning, that new name also you can give it as an argument. Then size of operator determines the space occupied by that variable or that user defined data type or that new name assigned data type, how much space they are occupying in the computer memory. It is calculated and that value is returned by the size of operator, and that value you have to interpret that it is in number of bytes only. If size of operator is returning a value 10 means you have to interpret that the 10 bytes space is being occupied. If size of operator is returning a value 50 means that variable or that data type or that structure is occupying that 50 bytes of space in the computer memory. Like that every value, size of operator, whatever value it is returning, that value is treated as in terms of bytes. It returns integer value, that integer value is interpreted in terms of bytes. This is the program which shows the significance of size of operator and typedef operators. Now I am giving some programs for your practice. You can execute all these programs on your computer. Try to develop program on your own. Here you have to, this program you have to write using structures within structure. Already student structure, we have been working with student structure. It contains all these member fields. Our question is, for storing all these marks of the student, 6 subject marks followed by total marks and percentage, you can have your own structure definition for these marks and name that structure definition as marks definition. That is what the first program. Write a program using structure within structure by defining structures called student structure and marks structure. Student structure should contain the member fields, student all ticket number, student name and marks structure variable. Marks structure also you are creating. Marks structure variable should contain member fields, marks scores of the student in 6 subjects and total marks of the student and then percentage of the student. Read the values from the user and display all the details of the student on the screen. Here for this program, first you have to define marks student structure and then you can define student structure. Inside the student structure, you create a variable of marks structure and you can call that marks structure variable as M or MR or MRK marks. Like that you can use marks structure variable inside student structure. Then reading the details are very similar to the student structure program. Student structure program you have to little bit modify it. Then the second program. Second program is your you have to implement the second program using arrays in structures. Already we have been using arrays inside the structures in all our programs. Again, you can write. You can develop a program by defining a structure with the name person, with member fields, name of the person, house number, and then street, land name, landmarks, district, and then state. So for each of these member fields, you can use array of characters, because name of the person is array of character, house number is only integer, or you can use it as also array of character, because you are having house numbers like 94 divided by 33 dash 54 by C, like that. So you can use array of character, and street is also array of character, landmark is also array of character, district is also, district name is also array of character, state name is also array of character. Means a person structure you are defining with the member fields, name of the person, house number, street, landmark, district, and state. 6 member fields. All 6 member fields are array of characters. Each member field you can declare with appropriate size and read those things from the user, and then store them inside that array of characters. And then you can display the details of the user. Means this is the address program. It stores the address of a person, and the complete address details of that person you have to display on the screen. This is the second program. It is also very easy. Just little bit you have to use your brain, think about the program, try to develop the logic part of the program on the paper, then write the program for this problem. Then go with assignments and important questions. Usually whatever questions were asked in the previous examinations and semester examinations, those questions are given as assignment to you. Here for this class I am giving 3 assignments. Try to answer after listening to the presentation of this video, this lecture. Take the notes and try to write the answers for these 3 questions. If you carefully listen to this video lecture, you will be having the answers for these questions in this lecture itself. Explain about arrays within structures. So this is what the first concept we have discussed. Explain it with an example. You wherever it is possible in C program, for every answer except 2 and 3 marks questions, for every other questions, 5 marks questions, 10 marks questions, you have to explain the concept with a suitable program. Remember it. Explain nested structures with an example. This is the second concept that we have discussed here. Nested structures means structures within other structures. Then discuss about Sizeof operator and typedef. Sizeof operator and typedef. This is the third concept that we have discussed in this lecture. So my advice is carefully listen to this video lecture, and if you are getting any doubt at any point of this video lecture, replay it, listen to that lecture so that you will be getting clarification. Still, if you do not have the clarification for the doubt, then you can contact me. I hope you know my contact number, that is 9848919656. I will be available to you between 9:30 a.m. and 5 p.m. on all working days. Thank you. Thank you all for your patience listening. Thank you.